Good day, Dr. Aimi and everyone. Welcome back to our second lab report video. I am Vanessa and today my group will be presenting our lab report regarding on producing soap from used cooking oil. With that, let us start from my dear teammate Nur Shakila.
For the introduction of this experiment is, soap is a fatty acid metal salt of sodium citrate or potassium oxalate. It is produced through the process of the sedification or simply through the process of hydrolysis of esters found in ammonia esters, which are common chemical types. Sodium hydroxide, which is known, or potassium hydroxide, GO, which is a reagent used to hydrolyze ester bonds with the bonds between the fatty acids and glycerol and produce fatty acid metal salts. Fatty acids are formed as lipid units called esterification to the cell with the formation of three esters most between. In the sedification process, there is a release of soap and glycerol that occurs because one of the ester bonds is broken by the base. Other types of oil and fats that can use when preparing this smooth soap include vegetable oils such as coconut, olive, and palm oil. Animal-based oils such as tallow and lard can also be used in soap production. For example, palm oil is composed of different fatty acids and has a characteristic soap forming effect compared to other oils. Next, for the objective of this experiment is to produce soap from used cooking oil through the purification process, and then the experiment aims to recycle used cooking oil into useful products, thereby promoting sustainability and reducing environmental waste.
So I'll be listing all the materials that we use during the experiment. Firstly is 150 ml of used cooking oil, 150 ml of coconut oil, a bowl, essential oil, silicone mold, food coloring, hand mixer, thermometer, 50 gram of sodium hydroxide, safety glasses, glove and lab coat, 500 ml beaker and 100 ml beaker, cloth filter, and lastly 180 ml of water. Thank you. So now I'll be explaining about the methodology. Firstly, 150 ml of filtered used cooking oil and also coconut oil each were measured. Secondly, 50 gram of sodium hydroxide were mixed in 100 ml of water. The temperature were measured and will cool down until it reaches 60 degrees Celsius. Next, the sodium hydroxide were added to oil and it was stirred continuously for 30 minutes until the solution precipitate white color solids. After that, food coloring, essential oil, and 80 ml of water were added and it continued stirring it. Lastly, the soap solution is poured into the silicone mold. It was left for drying for about 24 to 48 hours. Thank you.
Next is the result. Based on the result obtained from our experiment, we made some main observations about the soap's properties. First, the soap had a soft and smooth texture, indicating it was well made. In terms of color, it had a yellowish tint before we added food coloring, which was affected by the frequent use of oil before production. The soap also had a strong smell as it still carried the scents of used cooking oil with subtle hints of fish and other substance. Additionally, the soap's pH was highly alkaline with a pH value of 13.
Okay, first off the discussion, let me briefly share that the pH level for our soap is 14, which indicates a very alkaline or basic solution, which is significantly higher than the neutral pH of 7. In the context of producing soap from used cooking oil, this high pH is typically due to the presence of sodium hydroxide, which is commonly used in the saponification process. During saponification, the lye reacts with the fatty acid in the cooking oil to produce soap and glycerin. The alkaline nature of lye raises the pH of the solution, facilitating the breakdown of fats into soap.
Firstly, the process that carried out in this experiment is the saponification process. The saponification process involves the breaking down of triglycerides in used cooking oil through a reaction with sodium hydroxide that producing glycerol and soap as end products. Sodium hydroxide functions as a catalyst in the hydrolysis process, which is breaking down the ester bonds present in triglycerides to release fatty acids and form sodium salts known as soap. During the processes, even after filtering removes big impurities of used cooking oil from the beginning, residual traces can still impact the soap's texture, color, or fragrance, which is highlighting the significance of preparing properly in the beginning. Then, adding coconut oil that contains high levels of lauric acid into the used cooking oil can help create a firmer soap bar with better leather, improving the feel and effectiveness of machine. In this experiment, soap utilizes a mixture of coconut oil and used cooking oil, which have different fatty acids, to strike a balance in its lathering, firmness, and moisturizing qualities. Next, after mixing the sodium hydroxide in water, it is essential to keep the reaction mixture below 60 degrees Celsius temperature to avoid overheating, as it can lead to discoloration, uneven texture, or undesirable odors in the finished soap. During the part of stirring the solution, it must be consistently stirring during the reaction, which helps evenly mix sodium hydroxide and oil, resulting in even saponification and consistent soap texture. Moreover, adding essential oils improve scent and skin benefits, making the soap more appealing and beneficial through customization.
And today I'll be presenting about the question and also for the conclusions. So for the question, the first question is, what is the reaction involved in this preparation of the soap? So the reaction that involved is the saponification, which is the process of hydrolyzing triglycerides, which is fats and oil, using a strong base such as the sodium hydroxide. During the saponification, the ester bonds in the triglycerides are broken that yield glycerol and fatty acid salt. So the second question is, what is the pH of the soap before and after drying the soap? So before drying, since the soap solution is alkaline and contains unreacted sodium hydroxide, the pH is usually high and frequently above 10. But after drying, the pH usually drops a little bit, but stays alkaline between 8 to 10, because drying and curing reduce the amount of residual sodium hydroxide that may be still there. Third question is, what is the function of the coconut oil in the preparation of the soap? So myristic and lauric acids are the two fatty acids that have been found in the coconut oil that will create a soap that is firm, cleaning, and lathering. So the ability of the soap is to create foam and clean efficiently is facilitated by these two fatty acids. And the last question is, what is the role of sodium hydroxide in this experiment? The reaction saponifying ingredient is sodium hydroxide that breaks down fats and oil into glycerol and fatty acid salt, which make the soap by hydrolyzing the ester bonds in the triglyceride in order to transform the oil into solid soap, which means that sodium hydroxide is required. So in conclusion, the experiment successfully demonstrated the saponification process for producing soap from used cooking oil and coconut oil, and the final product had a smooth and soft texture, indicating a proper saponification reaction, although some characteristic of the used oil influenced the soap properties. And then the initial yellowish color of the soap prior to adding food coloring was likely due to the breakdown products of frequently used oil, and the residue of smells, reminiscence of fish and other substances suggest that additional purification steps such as the further filtration or adding some essential oil could help in the masking the odor in the future batches. Overall, these experiments highlight both the potential and challenge of recycling used cooking oil in the soap production, demonstrating that while effective, additional adjustment may be required to enhance the aesthetic and sensory qualities of the soap. That's all for me. Thank you and Assalamualaikum.